My name is Kelly Patterson, and I am the clinical nutrition educator with OmegaQuant, and I'm going to be talking about the omega-3 index. Let's go ahead and get started. All right, so we're going to be talking about the omega-3 index and a little overview of omega-3 fatty acids, then what the omega-3 index is, some normative values, how those normative values have been created, and omega-3 is kind of their mechanism of action in the body, and treatment, what we can do to affect omega-3 index levels. So, a little overview on what are omega-3 fatty acids. So, omega-3 fatty acids are polyunsaturated fatty acids with their first double bond on the third carbon from the omega end of the molecule. These are some images of omega-3 fatty acids. And omega-3 fatty acids are considered essential to our diet. We cannot produce omega-3 fatty acids from scratch. While we can convert certain omega-3s into other omega-3s, taking some versions to a different version, we cannot create them from scratch. So, they are essential for our diet. And our focus at OmegaQuant are two of the omega-3 fatty acids that come primarily from marine life. So fatty fish, and those are EPA and DHA. So, like I mentioned, there are really three different types of omega-3 fatty acids that we care about, but the primary one of importance are these EPA and DHA. So, the other types of omega-3s that are of importance to humans are what are called alpha-linolenic acid, and these are found primarily in plant sources. So, these are the omega-3s that are found in flax seeds, walnuts, pumpkin seeds, canola oil, things like that. And these are healthy and important for health, but they're fairly easy to get into the diet, and they don't have this alpha-linolenic acid does not have the same effect on the health effects that we're going to talk about that these other ones do. So alpha-linolenic acid are these 18 carbon chain fatty acids, whereas the EPA and DHA that we're discussing and are measuring with the omega-3 index are these 20 and 22 carbon chain fatty acids. Okay. Humans are able to convert some of this alpha linolenic acid into EPA, and some is able to be converted into DHA and back and forth. But this is a really inefficient process, and we don't convert very much. So we really primarily need to be taking this in exogenously, whether from food or from a supplement, in order to get adequate amounts. And we'll talk about what adequate amounts are and sources of those in the diet a little bit later. So the omega-3 index. So now we've covered what are omega-3 fatty acids. We'll talk a little bit more about the health effects of those and why we care so much about omega-3s in a little bit later. But what is the omega-3 index? The omega-3 index is unique to OmegaQuant, and one of the researchers who discovered the omega-3 index is the founder of OmegaQuant. So this is our kind of flagship test. It's unique. Again, OmegaQuant is the only place that you can commercially get the omega-3 index. We're really, really proud of it as a test. It's our most popular test for sure. So what exactly is it? The omega-3 index is a measure of the percentage of the fatty acids in our red blood cell membranes that are omega-3s, specifically that EPA and DHA. So this is what red blood cells look like. They kind of look like little, almost frisbee or donuts without a hole, kind of like a jelly donut type shape. And around the outside of all cells, but around the outside of red blood cells is a cell membrane that is this phospholipid bilayer, as it's called. So these little balls with tails on the end of it are fats. These are fats. The head is a fat, and then off the end are chains of fatty acids. So there are many different types of fatty acids. Each little ball with the fatty acid chain, each one is a different type of fat. Okay, so there's all different types of fat made up of that make up these cell bilayers. a certain percentage in everybody's red blood cells is made up of EPA and DHA. So what the omega-3 index is we take a look at your red blood cells and these red blood cell membranes and determine what percentage of your fatty acids in that membrane are EPA and DHA. So for this example, there are 64 fatty acids in this model membrane, okay, 4 of which are EPA and DHA. So 4 over 64 is 6.25%, and that would be this person's omega-3 index. So we're just taking a look at that cell membrane, red blood cell membranes, and determining the percentage of fatty acids that are EPA and DHA. And I'll talk about this range on the bottom in a little bit, but that 6.25% in this example would be the omega-3 index. So the omega-3 index is a measure of the amount of EPA and DHA in red blood cell membranes, and it's expressed as a percent of total fatty acids. So why red blood cells? It is possible to measure EPA and DHA in the plasma of our blood. Why wouldn't we want to do that? Well, the reason being is that plasma markers or plasma EPA and DHA are not stable, okay? What that means is that they are very responsive to changes within the day, within the hour. If you eat a meal really high in EPA and DHA, let's say you have a meal with salmon in it, your plasma DHA, most likely in that case, is going to shoot up really quickly within a relatively short period of time after eating that meal, which means if we check the plasma amount of EPA and DHA, we're getting your status right then. It's a momentary, in the moment, what is your status right now? It's kind of similar to checking fasting blood sugar or blood sugar right in this moment versus checking something like our hemoglobin A1C, which is a measure of over a longer period of time. Red blood cells is a more stable marker, and it reflects a longer period of time because of the life cycle of red blood cells, which is about 120 or 90 to 120 days. So 3 to 4 months, we get a much longer look at your total. It's more representative of your total intakes of omega-3s versus what you ate this morning or what you ate this afternoon or what you've eaten in the last few days, because that's not really helpful when we're talking about long-term health markers and health changes. So red blood cells is a lot more stable over the long term, whereas plasma goes up and down with your intakes. Of course, your plasma, if you're not eating a whole lot of, EPA and DHA in general, might be a little bit more stable. But maybe you eat, something some days and not the others. It's going to be much more variable, and that's not what we really want to see. We really want to have a reflection of your total picture of diet and lifestyle. So red blood cell also is correlated really, really well to tissue levels of EPA and DHA. So in this particular study, blood and organ tissues were collected. This is in mice, but the same is true for humans, that in the case of plasma, we're not seeing that correlation between tissues and the plasma markers, whereas with red blood cells the correlation is there. So we know that if your red blood cell membranes have the appropriate amount or optimal amounts of EPA and DHA, then the same can be said for your tissues, where the health effects can be seen really beneficially, especially in cardiovascular tissue, lung tissue, muscle tissue as well. And we'll talk a little bit about kind of what those effects are in a little bit. But there is a high correlation between the red blood cell EPA and DHA levels and tissue, organ and tissue, blood and tissue levels as well. So what are ideal levels? We saw this chart on the earlier slide of what the omega-3 index is. So talking about typical versus desirable, there have been, so I'm going to skip ahead to the next slide actually really quick, and then I'll go back. So typical versus desirable. This is a kind of amalgamation, a gathering of a bunch of epidemiological studies in comparing the omega-3 index with specifically cardiovascular and longevity outcomes. So reduced cardiovascular death, reduced cardiovascular events, such as things like heart attacks, strokes, et cetera, deaths from cardiovascular events. and just longevity. How long are people living? And what we found after taking the averages where these events are much, much lower and controlled for other lifestyle choices as well, is that the desirable range for the omega-3 index is somewhere between 8 to 12%. That's where we would like to be. Okay. This lower range, when I go back to the previous slide, we'll talk about kind of what that looks like. And that's where we see those increased incidences, right? So increased likelihood of cardiovascular disease, cardiovascular events, and death, early death from cardiovascular events, among other things. So the desirable level is between 8 and 12%. So 8 to 12% of your fats in those red blood cell membranes being EPA and DHA. What happens if you're above 12%? So it can happen that people are above 12%. It's not super, super common. But really there's no harm in being above 12% that we have seen. And that the research has borne out. There really seems to be no harm, but there also doesn't appear to be any additional benefit. So while you certainly can aim for being above 12%, there isn't really any more bang for your buck in getting up that high. So really for most individuals, we want to be between 8 and 12%. Okay. So I'm going to go back to the slide here with these different countries. And this is where we see different countries and sort of lifestyle starting to come to the surface. We see here on the left, US vegans and military. So why do we point out vegans? And it's really because they're not getting any of those marine sources of omega-3s. They tend to, them and military, and there's a lot of multifactorial reasons why military levels are so much lower: increased oxidative stress from training, poor diet quality, things like that. US vegans, people living in the United States that are vegans, and people in the military tend to be seen on average having the lowest average omega-3 index levels. Okay. And again, it's mostly because of the diet quality, but for the military, it can also be that increased oxidative stress. Average in Canada and the United States is somewhere between that 4 to 6%, usually landing around 4.5 to 5%. Is what our average omega-3 index levels. And if we think about it, that makes a lot of sense. Fish, especially cold water fatty fishes, are just not a huge part of kind of the standard American diet. If you go to the grocery store, a lot of those types of things are much more expensive. Things like chicken, beef, pork tend to be a lot cheaper. They're a lot more accessible. Getting good, high quality salmon, herring, mackerel, those types of things, it's just harder, and it's really, really expensive unless you live in a coastal town where fishing is right there, and those things might be a little bit cheaper and a little bit more accessible. But for a lot of folks, especially in the middle of the country, those things are not accessible, and they're just not culturally part of our diet. Mediterranean nations, especially places like Spain, tend to have a little bit higher, although a lot of the types of fish they eat are not those cold water. They're not those higher fat fish, but they do eat a lot of seafood. And so they tend to get a little bit more than we do. Places in Scandinavia, they kind of range, between that 6 and 8%. They tend to eat a lot more fish than we do as well. And certain places eat a lot more fatty fish. Then we get into certain places in Asia, specifically Japan. Japan kind of consistently across the board has very, very high levels of their omega-3 index. And again, this makes perfect sense. They eat fish all throughout their lives. They eat a lot of very fatty fish: tuna, mackerel, salmon, all like sardines, herring, all different types of fish, and a lot of fatty fish. It's a huge part of their cultural diet, and they're eating it throughout their whole life cycle as well too. So they have high storage levels of EPA and DHA, and that's where we tend to see averages in the 8, 9, sometimes even 10%, depending on the population studied. Okay, so we already talked about this one. And so why these cut points? Again, I talked about really cardiovascular risk is the biggest reason for those cut points. And if we look at kind of the odds ratio, this is a kind of a meta-analysis of all 20 years of research kind of corroborates these original cut points. The massive reduction in risk when we get to above 8% of risk of cardiovascular events and death from cardiovascular events. So we see a 35% reduction in risk, which is huge, especially here in the United States, and in other, countries across the world that don't eat a lot of fatty fish. Cardiovascular disease is high on the list of things that kills us. It's a number one killer of men and women in the United States, and as well in, I believe, Australia as well. And so, we see these levels. If we can impact our risk of death from these types of events by any amount, even by something, especially by something that's as significant as this, by just adding something into our diet, we don't even have to take anything else away. But just adding more omega-3s in our diet, it seems like a simple, easy, straightforward way that we can improve health outcomes. So again, this is just a little bit of just a wrap up of some of the research, and these are all studies that, if you're interested, to take a look at, studies showing that these higher versus lower omega-3 index are decreased risk for heart disease. They have better cardiorespiratory fitness. They're less likely to have loss of cognitive function earlier in life, lower incidences of depression and anxiety, and also, interestingly enough, age-related macular degeneration, which makes a lot of sense. DHA is super crucial in eye development and eye health. It's one of the reasons why omega-3s are so important for pregnancy, because of eye development, DHA specifically. So it makes sense that age-related macular degeneration would be affected by omega-3 levels. Longer life, so longevity just in general, has been associated with higher omega-3 indexes as well, in several studies. Those are just two right there. So if you're interested and you want to take a look at these studies and read for yourself some of the research, I highly recommend it. These are just some of the health benefits for omega-3 index. So I'm going to kind of go through some mechanistic, how does this all work? And really the biggest spot for one of the biggest places where omega-3s play a role is in inflammation management. So the inflammation process, inflammation is kind of seen as we don't want so much inflammation, but we need inflammation to survive. Inflammation is a crucial part of our immune system, and to heal any injuries. So a really good example is, if you were to get sick, get a virus, something like that, and you start feeling cruddy, you get a fever. Well, the fever is your immune system kicking in to fight the virus, right? This is an inflammatory process. If you sprain your ankle or, whack yourself on the arm, right? You walk to a door or something like that, right? And you get a bruise and it swells and it hurts. That is your inflammatory processes doing what it's supposed to do. It's isolating the damaged tissue, cleaning out some of those damaged metabolites from the injury, and shuttling them away, clearing them out, so that that damage doesn't spread, so that the tissue doesn't die. We need inflammation. Inflammation is a really, really good thing. The problem is when you see this acute inflammation here doesn't resolve. When that does not resolve, we end up seeing things like chronic inflammation. And these can be seen in conditions like colitis, irritable bowel disease, arthritis, neurological diseases, cancer, obesity. And so these are diseases of chronic inflammatory processes. You can also see tissue organ injury like spinal cord injuries, kidney injuries, damage from other diseases that are unresolved inflammatory processes. And these can be set off by a number of different things. It's not necessarily just an acute injury, illness. It can be something that builds up over time. But when that inflammation is not resolved, it becomes chronic inflammation, and then the tissue can start to become permanently damaged. Okay. Omega-3s are part of those resolving chemicals, help create SPMs, which are specialized pro-resolving mediators that help reduce inflammation, and kind of calm down that chronic inflammatory process. And omega-3, specifically EPA and DHA, are essential for the creation of those SPMs. So this is a little bit more complicated of a diagram. Pause if you really want to take a look, kind of read everything. Really, the thing I want to focus most on that is this change in membrane fluidity. So I talked about how EPA and DHA are incorporated into the cell membrane in red blood cells. They're also incorporated into the cell membranes in our tissues as well. And so when our cell membranes are more fluid, they're less likely to be damaged. It's a little more complicated than that, but that is part of, we want fluid, healthy cell membranes, and having enough EPA and DHA embedded into those cell membranes is really, really important. There are a whole host of other mechanisms that I'm not going to go into, so we can keep this video short, but pause to read if you'd like to, and we have other PowerPoints on our YouTube channel that go into this a little bit more in depth. And these benefits show up all over the body, right? So having this cellular membrane fluidity and some of these other anti-inflammatory benefits show up in the heart, in our liver, in our blood vessels, right? Decreasing blood pressure is a really good example. Again, keeping our blood vessels nice and soft and not being rigid. Omega-3s can help with that. They decrease that vascular resistance. So it happens when your arteries start to get really hard, and improve compliance. So meaning your arteries and veins can stretch the way they need to. An interesting one here is thrombosis. So there's a decrease in thrombosis, meaning you're at a lower risk for blood clots. However, for a long time, there was a belief that taking high doses of omega-3s or fish oil could increase bleeding risk. But really, research in the last several years has come out to show that there actually is no increase in bleeding risk from taking omega-3 fatty acids. So taking your fish oil is perfectly safe. Talk to your doctor, of course, if you're making any changes or if you have any underlying health conditions. But it is important to note that research has shown that it does not, taking omega-3s does not increase bleeding risk whatsoever. In fact, several studies have shown that after surgery, patients who are taking omega-3s, fish oils, are actually at a lower risk of bleeding events than people who are not taking them as well. So we see these health effects, these anti-inflammatory effects, this improved cell membrane liquidity, mobility, all over the body, which then yields these results that we see, reducing cardiovascular risk and such. So I'm going to move on to what do we do about our omega-3 index? How do we get it up to, that 8 to 12%? So this is an example of how we really want to take kind of a multi-step approach. We want to come at this from all different angles. And I'll talk a little bit about the test itself in a few minutes. The omega-3 index, though, this is how in a study, the omega-3 index was affected by both a supplement and eating fatty fish several times a week. So you can see at the bottom, it's the number of times per week that someone was eating the fatty fish. And then the dark blue is the people who are also taking a supplement along with that. And the light blue was the no supplement. So down here at the none per week, if you're not eating any fatty fish at all, and you're not taking a supplement, you can probably expect your omega-3 index to be somewhere around that 4.3%. It's very variable between individuals, but if you really don't eat anything and you're not taking any supplements, that it could be your number, right? And in this study, when these individuals took a supplement for a period of time, it was about 3 months, they were able to raise their omega-3 index pretty significantly, but they're still not to that omega-3 of 8.3%. With a higher dose and more time, it's possible they could get that level up. But then we go all the way over here to the 3 times per week. So these are the folks who are eating fish 3 times per week at baseline, and then we add a supplement onto it as well, and they were able to get into that 8.3% number pretty easily there. Okay. So this is just to show you that we want to kind of come at this from multiple angles. So the first one, and really the